Okay, so here is a question that asks us the side length of the cube, but it only gives us a to h correct to the nearest millimetre. So let's have a look. So this basically means that to get from A to H, we have that length. Okay, and that is 22.7 centimetres correct to one decimal place. Okay, so it talks about a lower bound for the length of the edge of our cube. So it's a cube, so also the lengths are the same. So let's think about our lower bound for a start. So if we've got a line which is 22.7, what's going to be our lower bound? Well, that's going to be 22.65, and that's going to be 22.75. So the lower bound is here. Right, now we need to work out the length of one of our sides. So the best way to do this is let's call our side A. Okay, so our side length for this is A. So what we do first, we're going to put a triangle here on the base. Okay, and we know that that's a right angle because it's the bottom of the square. Okay, so if this side is A, that side is A. Right, so that means that I've got a triangle, side A, side A. Now I want this length because that's going to form the base of the vertical triangle. Okay, so I know that if that's A and that's A, this side is square root of A squared plus A squared. Okay, so that's my A squared plus B squared is C squared. But here they're both the same, so it's just A squared plus A squared square rooted. Okay, so now I've got that. Now I'm going to put a vertical triangle on top of that base. Okay, so now that's my second part. Now I've got the vertical triangle. Now I know that this part, okay, the hypotenuse, because that's opposite my right angle, I know that this is 22 point, well, it's got 65, this is a lower bound. Okay, and there's my right angle. Now I know the bottom part of that is this. Okay, because that's what my base is sitting on top of. So this is the square root of A squared plus A squared. Okay. Now remember that this side is actually one of the sides of our cube. So again, that's just going to be A, because all the sides are the same length. Right. So now to work out this, what I need to do is I need to take square root this plus square root this. Our A squared plus B squared is C squared. So I've got A squared plus the square root of A squared plus A squared, and that's all squared. That's my side length, so I square it. That equals 22.65 squared. So this is basically just Pythagoras. Okay? So that's my A squared plus B squared equals C squared, which is the hypotenuse. Okay, so now A squared is just A squared. Now, if I square this bracket, I multiply by itself. Remember, a square root times itself is just the thing inside the square root. So I've got A squared plus A squared. So let's collect these together. I've got 3A squared is equal to 22.65 squared. So now, all I have to do is divide this by 3. So A equals 22.65 squared, all divided by 3. And that gives me that A is equal to 13.08. And the mark scheme said your answer needs to be between 13 and 13.1. So anything in that range will give you that. That's fine. Right, now, Harry was asking about doing this with SOHCAHTOA. So let's have a look at doing it with SOHCAHTOA. Okay, so if I'm going to do it with SOHCAHTOA, or try and do it with SOHCAHTOA, I'm just looking at this triangle, the vertical triangle. So here's my triangle. Okay, this is my point A. That's my point down there, H, and that's my point at the back, F. And there's my right angle. Okay, so now I know that this is 22. That's the same thing. We'll say the same. The lower bound of 22.65. Okay, and if I know this angle, then I could use the opposite over the hypotenuse and use sine. And then it means basically that sine of that angle equals the thing that I want, that side length, over 22.65. Now, there is a problem. This length at the bottom here is not the same as A. So that is not equal to A. Let's think why. Okay. It goes across the bottom of that triangle, the bottom of that base. So if this is the bottom of my cube, okay, so I've got F here, G here, H here, and E here. If I draw a line across, okay, let's take an example. Okay, we'll put it into numbers, make it easy. If I say that this is 3 centimeters, that means that this is 3 centimeters. Here's my right angle. That's 3 centimeters. That's 3 centimeters. So that line across is the hypotenuse of that triangle. So that means I've got 3 squared plus 3 squared is equal to c squared. So that's 9 plus 9, so 18 is equal to c squared. So c is equal to the square root of 18. Okay, and the square root of 18, if you remember simplifying your surds, I can take out, that's the square root of 9 times the square root of 2, which is 3 square root 2. Okay. Now that is not the same as that. These two are not the same. So this side is not the same. So basically what happens, that means that actually this isn't, when I put something on top of this base, so when I put this triangle on this base is 3 square root 2, and actually my triangle is like that. My base is longer than my side. Okay, so if this was 3 and this is 3 square root 2, that side's longer. So this angle here is not equal to 45 degrees. Okay, it's only 45 degrees if both sides are the same length. So if I had a triangle where I got 3 and 3, that will be 45 degrees. Okay, because that will be 45 degrees, because this is an isosceles triangle. Okay, and our one is not an isosceles triangle, so we don't know that angle. And we don't know the angle, we can't use SOHCAHTOA, because in SOHCAHTOA we need 2 pieces of information to find the third one. In the same way that with Pythagoras we need 2 lengths to find the third length. So, as we started off saying, this is a 3D Pythagoras question, okay? And this is how we solve it.